Hello children, so we'll be doing very important topic which is prism formula. For that we need to draw a diagram to show refraction through a prism. So you can make a prism. This is incident ray, refracted ray, emergent ray. Okay, will produce incident ray back and emergent ray back. So this is your angle of deviation. Now let us draw normals at both the surfaces. So this is your normal, and here also this is the normal. Let normals meet. Now let us do the labeling. This is angle of incidence at first surface. This is angle of incidence at second surface between the normal and emergent ray. Incident ray and normal. Angle has to be between normal and the other ray. This is normal ray. Similarly, this is normal ray. Now, this is angle of refraction at first surface. Again, one line has to be of normal. So blue is normal. This is angle of refraction at second surface. And this is called angle of prism. This angle we can take x. Okay, so after labeling these things, we'll be starting our derivation. You can see r1 plus angle r2 plus angle x is equal to 180. Angle sum property of a triangle, right? This is a triangle. R1, this angle is visible. R2 and x. So sum has to be 180 degree. Now similarly, angle A plus x is equal to 180 degree. Okay, because in this quadrilateral, let it be TSPN. These two angles are 90-90. This is 90. This is 90. So sum is 180. So rest of the two angles sum will be 180. Total sum has to be 360. Okay, I have dotted here. This is normal, no? So this is 90. This is 90. 90 plus 90 is 180. So rest two angles of quadrilateral will have the sum 180. So put them equal. Both are equal to 180. So put them equal. X cancel. So R1 plus R2 is equal to angle A. This is equation number 1. We'll keep this relation. Now we will see. Now we'll see further. Angle of deviation is here. This is the angle of deviation. You can see this much portion is R1. This full was I1. So this is I1. So the remaining angle here would be I1 minus R1. Let it be angle 1. Okay, so angle 1 would be I1 minus R1. Let us look here once again. Look, this is I2. So vertical opposite angle. This will be I2. Right? This is I2. But the lower angle is, this much angle is R2. So this angle 2, you'll have to label in your diagram. That angle 2 would be I2 minus R2. I2 is full, and if you are subtracting R2, you are getting this upper one, which is I2 minus R2. After that, now we have angle 1. we have angle 2. This much is angle 2. Okay. And you can see in this triangle, delta is exterior angle. So exterior angle will be sum of interior opposite angle, that is angle 1. Denote like angle 1 plus angle 2. Let us substitute the values of angle 1 and angle 2. So yes, angle of deviation would be equal to I1 minus R1, that is the value of angle 1, and I2 minus R2. So we can write it as angle of deviation equals I1 plus I2 minus common R1 plus R2. Now what is equation number 1? Let me pick. This is equation number 1. R1 plus R2 is A, angle A. So from equation number 1, what do we have? R1 plus R2 is equal to A. Let us substitute here. So angle of deviation will be equal to I1 plus I2 minus A. So for this angle to be minimum, for angle of deviation to be minimum, this quantity should be minimum. Let us write it further, then we will see. So we are just writing it. I am writing I1 as root I1 square and I2 as root I2 square. Root and square will be cancelled, so it will again be I1 and I2. So no problem. So we have written it like this. Then delta we are picking up. This is root I1 square plus root I2 square plus twice of root I1 root I2 minus A. We have added twice of and we have subtracted twice of root I1 root I2. This term we have added, this term we have subtracted, so no change. So we can do it. Now subtraction wala we are keeping first and addition wala we are keeping later. So this becomes your A minus B whole square. Okay, and next is 2 root I1 root I2. So this is my angle of deviation. Now for delta to be minimum, see minus A is also there. Yeah. So this is the final equation that I've got. Now for this to be minimum, for angle of deviation to be minimum angle of deviation, this quantity should be 0. Others cannot be 0, this should be 0. Right? So you will write root I1 minus root I2 whole square should be 0. So that means square will go that side. That means root I1 minus root I2 should be 0. That means root I1 should be equal to root I2. That means I1 should be equal to I2. So this is a condition for minimum deviation. So we will remember it, that for angle of deviation to be equal to minimum deviation, I1 should be equal to I2. So let us substitute and let it be equal to I. Let us substitute in this equation. This we considered as 0 for this to be minimum. So write the equation. Del M minimum is equal to, this is 0, Forget about it. Okay, so let it be. We have got, we need not write this. Let us see. It should be equal. Right now, let us go to that equation in which we have this. So write down this, the relation between angle of deviation and angle of refraction. So let us write that equation. Del is equal to I1 plus I2 minus A. So it is minimum angle when both are equal, I plus I minus A. So minus A will go this side. So A plus del minimum is equal to 2I, and I equals A plus del minimum deviation by 2. So this is another equation which we have to remember. Equation number 2, 1, 3, all we need to remember. So let us see further. Now we know for minimum deviation, what do we know? For minimum deviation, what relation do we have? I1 is equal to I2 we have. So let us write Snell's law at first surface. So that will be sin I1 by sin R1 is equal to, see if you remember, this is I1, this is R1. So we are going from air to glass. So that will be equal to your, where are we going? To glass from air. Mu air is 1. That is mu glass, or you can write mu 2. Okay, now we have this equation. Okay, now similarly for the other surface we can write when light will enter like from this side. So this is I2, this is R2 for the other surface. This is R2. We have seen in the diagram already. So similarly we can write at other surface sin I2 by sin R2, that is equal to mu glass by mu A from other surface, right? So put them equal. They both are equal to mu G by mu A, no? So put them equal. So that will be equal to sin I1 by sin R1 is equal to sin I2 by sin R2. Now I1 is equal to I2. Okay, that means sin I1 is equal to sin I2. So this will be cancelled. Okay, so it will be equal to 1 by sin R1 is equal to 1 by sin R2. So sin, or you can say, you can reciprocate. Sin R1 is equal to sin R2. Basically R1 is equal to R2. This is what I wish to show. So I use Snell's law at first surface and second surface. While entering, I wrote while entering from this side, I wrote sin I1, sin R1 is equal to mu glass by mu air, and while entering from this side, I wrote the same, sin I2 by sin R2. Just put them equal, you will get this. So for minimum deviation, this is also true. For minimum deviation, R1 is also equal to R2. Now you have to pick equation number 1. Derive this simultaneously in your notebook, and whatever is equation number 1, which is this, just write it once again. Now R1 is equal to R2 is equal to R, you can take. Let us substitute. So R plus R is equal to A. 2R is equal to A. So angle of refraction is equal to A by 2. A is your angle of prism. So this is my last relation. I got the value of R and I got the value of I. This is I. So just write it again. I and R together. This is R and this is I. Del minimum plus A by 2, or A plus del minimum by 2, we write generally like that. Okay, now we can write value of I and R in Prism formula, that is sin I, in Snell's law we can substitute. It is equal to mu glass by mu air, or you can say mu 2 1, mu 2 by mu 1. Substitute I and R. I is this, substitute A plus del minimum by 2, R की वैल्यू भी रखो, sin A by 2, R is A by 2. Yes, so this will be equal to mu 2 1, or mu glass with respect to surrounding, or mu glass with respect to air. है ना, so this is your Prism formula. This equation is known as Prism formula. Very important. Okay, now we have a thin prism formula. That is special case, right? When the prism is very thin, thin prism formula. So we know for thin prism, yani ki for small angles, what do we know? Sin theta is approximately theta. So we'll write this as A plus del minimum by 2, and lower quantity will write A by 2. This will be equal to mu 2 1, mu 2 by mu 1. Right, 2 will be cancelled. So we have A plus del minimum by A is equal to mu 2 1. I am denoting it as mu, but I know that it is mu glass with respect to air or surrounding. Just for the time being, I am just denoting by mu. It is mu glass. Okay, now A will go that side. So A plus del minimum is equal to mu A. So del minimum is equal to mu A minus A, and del minimum is equal to mu minus 1 into A. This is thin prism formula. Okay, mu, we will remember that mu is mu glass with respect to surrounding, mu glass with respect to air, and this is written as mu glass by mu air. Then we have this graph between angle of deviation against angle of incidence. Okay, so this is an experiment as well we used to do in lab. Okay, so it is like this. So when we plot angle of deviation against angle of incidence, then initially when this angle of incidence increases, like 30 degree, we get some value. Okay, for 30 degree we are getting some value 40. Then 45 degree it increases. Then 50 degree it decreases. Now it is starting decreasing. Angle of deviation decreases. It reaches a minimum value. This is called angle of minimum deviation. Sorry, first it decreases, then it increases. Yeah, so I told that it is increasing. No, we can see from the graph. What does graph say? Let me plot it once again. Angle of deviation against angle of incidence. As you increase it, it decreases. It reaches a minimum value, then it starts increasing. So this is called del minimum. Okay, as I increases, the deviation angle decreases, reaches a minimum value, After that it increases. So you already know that at minimum angle of deviation, the value of angle of incidence is equal to I1 is equal to I2. ठीक है, and what is the value of minimum deviation? It is A plus, sorry, plus A is equal to 2I. This is not to be written, the graph is to be drawn.